Alright guys, so this is the video to go over the notes for section 9.5, and in this video we're going to graph tangent functions. So there's a lot in here about tangent and cotangent, but we're simply going to worry about tangent. Okay, you could probably figure out cotangent the same way we're figuring out tangent, but we're going to focus our attention mainly on just tangent. So what I want you to do with a partner, okay, go ahead and get out your unit circle if it helps. I want you to go and find the numeric value of each one of these. Okay, so now remember, we know that tangent of theta is equal to the sine of theta over the cosine of theta. Okay, so if I do the first one together, so if we go to our unit circle and we go to negative pi over 2. Okay, so that would be right here at 90 degrees. Okay, so our points here is 0, negative 1. Okay, now remember, our x value is the cosine of theta, and our y value is the sine of theta. Okay, that's it, negative pi over 2. So if we put this as a fraction, sine over cosine, this would be negative 1 over 0, which anything over 0 is undefined. Okay, so I did the first one for you. I want you with a partner to go through with your unit circle and figure out the rest of these, write it as a fraction, and then kind of simplify that fraction. So this is what you should have gotten on this chart. Okay, so take a minute, look it over, look at your final answer, and we're going to use these here in a minute to graph the parent function of tangent. All right, so we are going to use that chart we just had to graph the parent function of tangent of x. So y equals tangent of x, or tangent of theta, or whatever you want to call it. Okay, now some of the important things is where we see that it is undefined, okay, that signifies that we have an asymptote. Now, we've talked about asymptotes before, and remember, asymptote is that imaginary line that we get closer and closer and closer to, but we never actually get there, okay? And so where we have asymptotes, or where this is undefined, we have asymptotes. So we're going to draw those just like we did before when we talked about asymptotes, and we're going to draw them with imaginary lines. So we are undefined when our x is negative pi over 2, and these are supposed to be straight lines, guys, hard on the slate. And we are also undefined when our x is pi over 2. Okay, and we're also undefined at 3 pi over 2. Okay, we're not going to graph every one of these points, but we're going to graph enough to get the main picture. Okay, now if I go back through, and the easiest point to plot is where our y value is equal to 0. Okay, so where it crosses the x-axis. Well, if you notice, we cross the x-axis at x equals 0. And we also cross the x-axis at pi. All right, now we're just going to look at a couple other points. Let's just look at the nice numbers. Okay, so we're at negative 1 when our x is at negative pi over 4. So that would be halfway between 0 and 2 pi. So right here. Okay, and then we're at positive 1 halfway between 0 and pi over 2. So right here. Okay, and then same thing over here. We are at negative 1 at negative pi over 3, which would be right here. And we are at positive 1 at pi over 6, which would be right here. Okay, now if we connect the dots, remember these are asymptotes, so we're getting closer and closer and closer to. So we're going to come somewhere like this. Guys, it's super hard to draw on the slate. Ooh, up like that. Okay. Or we're coming along this asymptote, and then we're cutting back, and we're going up again. So it's like this. Okay, so this would be the parent function of tangent of x. All right, guys, so if I wasn't on my slate and I drew this perfectly, this graph right here is about what it should look like. All right, so this chart in your note just tells you some basic characteristics of tangent of x. Okay, so first and foremost, our domain is everywhere except where we have asymptotes. Okay, and we have asymptotes at like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Okay, so we call this all real numbers except for odd multiples of pi. So think of this as 1. So odd multiples would be 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on and so forth. Okay, this also applies to negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, because just like sine and cosine, this graph repeats over and over and over again. Okay, now this is for the parent function of tangent of x. Okay, obviously we're going to mess with the periods and things like that, and that's going to change. But for the parent function, the asymptotes are odd multiples of pi over 2. The domain, okay, we're not going to talk a whole lot about cotangent, so I'm not going to go over that. Okay, the range is all real numbers. Okay, remember, one period does something like this, right? And it continues on and on and on, on and on and on, right? Never hits that asymptote, but it continues going up and it continues going down. So it continues, y continues to go to negative infinity and positive infinity, and therefore the range of this is all real values. Okay, something else to note, the period of each is pi, right? It's right in here between these asymptotes. We repeat this over and over and over and over and over again. So our period is just pi. That is also different from sine and cosine. And our x-intercepts, okay, is right between those two asymptotes, or it's at 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, so on and so forth. Okay, and once again, we're not going to do cotangent. All right, so let's go over some other things. Okay, when we're talking about periods, remember how much until we repeat again. Okay, well, for sine and cosine, our period we found by doing 2 pi over b. Okay, this is for sine and cosine. Okay, well, our period here is not 2 pi, but it's pi like we just saw. Okay, so rather than 2 pi over b, it's going to be pi over b. And remember, we're going to do the absolute value of b. Okay, the vertical asymptotes then would be pi over 2 times b. And once again, we're not doing cotangent. Okay, so we're going to use these in our next couple of examples. All right, so let's look at example 1a. We want to graph two periods. I don't need you to graph all 85 of them. Okay, we're going to graph 2 of 2 tangent of 3x. Okay, we're going to describe the graph as a transformation from just the parent function tangent of x. All right, well, let's do our transformations first. We've done this a bazillion times this semester, so this is something you should be familiar with. Okay, so this 2 indicates that we have a vertical stretch by a scale factor of 2. Okay, and then this 3 tells me, remember, it's on the inside. You can think of this as 3x, if you will. Okay, this is going to be a horizontal, and remember, we do the reciprocal of it, so it's going to be a horizontal shrink by a scale factor of 1/3. Okay, now, so to find my period, remember my period is going to be pi over absolute value of b. Okay, this is my a, this is my b. Okay, so my period is going to be pi over, well, the absolute value of 3 is just 3, so it's going to be pi over 3. Okay, now my vertical asymptotes, okay, I'm going to do pi over 2 absolute value of b, which is pi over 2 times 3, which is pi over 6. Okay, and we're going to do every odd multiple of this. So it'd be pi over 6, 3 pi over 6, which is pi over 2. Okay, 5 pi over 6, 7 pi over 6, so on and so forth. All right, so now let's graph this equation right here. Okay, so we're going to graph g of x equals 2 times tangent of 3x. Okay, now, just like we did before, this is my a, and this is my b, and if we want to put this in parentheses, we can. Okay, let's first write the transformations. This is something we should be very, very comfortable with. Okay, so this 2 tells me that I have a vertical stretch by a scale factor of 2. Okay, and this b tells me, remember When it's inside the parentheses, it's the reciprocal, so it's going to be a horizontal shrink by a scale factor of 3. Okay, so we have that. That's the transformations. So my period is going to be pi over absolute value of b. Okay, remember it's not 2 pi because our period for tangent is pi. Well, our b is 3, so our period is just pi over 3. Okay, so that's how we start, and we just repeat what happens at pi over 3. Okay, now our vertical asymptotes can be found by pi over 2b, which is pi over 2 times 3, which is pi over 6. Okay, well, pi over 6 is negative pi over 6 is. Okay, so think of that as like 1 pi over 6, and then we want odd multiples. So not 2 pi over 6, but 3 pi over 6, which would be pi over 2 and negative pi over 2. Okay, then 4 pi over 6 would be even, so 5 pi over 6 and negative 5 pi over 6, and we could keep going on and on. So negative pi over 6, pi over 6, negative pi over 2, pi over 2, etc. Okay, all right, so that should go right there. All right, so now let's draw this thing. Okay, so I'm going to go ahead and draw, let's do negative pi over 6 here, negative pi over 6, which means this has to be pi over 6, which means this has to be 2 pi over 6, which is just pi over 3. This has to be 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3. We have 5 pi over 6, and then we have 6 pi over 6, which is just pi. Okay, and let's just do these by increments of 1. So 1, 2, 3, 4, 5. We'll put a 6 here so we know what our scale is. All right, so first thing I'm going to do is I'm going to draw our vertical asymptotes. Now I only have to draw 2 periods, okay? But do remember that it keeps repeating forever. So I'm going to draw an asymptote right here. Remember, we draw that with dotted lines at negative pi over 6. And then we draw another one at pi over 6. So everything happens between those two things. Okay, well, that's 1 pi over 6. And then we have another one at pi over 2. And I could do negative pi over 2, but I don't need to because in between those two lines would be my 2 periods. All right, so we know it crosses in the middle of those. So I'm going to put my dot there and my dot there. Okay, now this is where the amplitude comes in. So my amplitude is 2. So that means halfway where I cross from here in my asymptote, my y value is 2. Okay. And then the other halfway here, my y value is negative 2. Okay, so once again, halfway between where I cross and my asymptote's 2. Halfway between where my asymptote and where I cross is negative 2. So now I can just connect the dots. So I'm going to ride this asymptote here. I'm going to circle between those lines and then write it up again. Okay, and I'm going to do the same thing here. Guys, it's really hard to draw on this slate, so my apologies. Okay, so here would be 2 periods of my g of x function. All right, so going back and looking at what we just did, I want you to pause this video, try to do this example by yourself. Okay, remember if there's nothing here, a value is just a 1. Okay, try to do this by yourself, and then we'll come back and check your answer. All right, so hopefully you work this one out on your own. Okay, so when you take your b is just 1/2, and you do pi over b, pi over 1/2, remember you divide by a fraction, same as multiply by the reciprocal. So you get that the period is 2 pi. So that means in 2 pi span of space, you start repeating your graph over and over. Okay, then you get your vertical asymptotes by pi over 2b. Okay, and so when you reduce that, you just get pi. So at negative pi, pi, and then odd multiples, so 3 pi, 5 pi, 7 pi, 9 pi, so on and so forth. But you could also go negative, negative 3 pi, negative 5 pi, and so on and so forth. So when you connect the dots, it looks like this. Now remember, your amplitude is just a 1, so that's why we go up to 1 halfway between. And guys, I went by increments of a half here. So if yours looks a little different, that's probably why. All right, if you're feeling good, you could probably do the worksheet for this section. If not, go ahead and pause this, do the monitoring progress, and we'll come back. All right, so this is what you should have gotten. It should have been super long and super skinny, okay, because that amplitude really stretches it out vertically.